Hi, welcome back for another day in lockdown, another element. Right, now before we go too far, I just wanted to pull up cesium one more time, quickly, please, because in the last video, my bad, I forgot to mention who discovered cesium. It was Bunsen, here's Bunsen, and Kirchhoff, here's Kirchhoff, with their wonderful spectroscope, which was basically a prism which breaks up the light. As you know, they named rubidium after rubidis, which was deep red, Latin, because of its spectrum. Here's its spectrum. And cesium they named after Cesius, which means Latin for sky blue. So sorry about that. There you go, cesium, bang. Now straight away onto our next element, francium. Now quickly, let's pull up its its atom. Here we have the atom for francium. As you can see, seriously big. Its atomic number is 87. So it's the heaviest element on the alkali group, and it's radioactive. I'll go into that in a second. But as you can see, there's 87 protons, 87 neutrons in the centre, 87 electrons whizzing around, and once again it's got that one electron in its outer shell, which makes it really reactive. Now, let's quickly pull up the card. Right, here we go, francium. Now, francium was discovered by Marguerite Perret just before World War II. And she was an amazing woman who not only managed to discover an element, and she had the right to name it. She was going to call it Technetium, but everyone thought it sounded a bit too much like a cat, so she changed it to francium after the country she was born in. But at the time when she was working as a lab assistant, she was working very much in a male-dominated scientific world, but she managed to forge herself a way and made herself a place in history as being the discoverer of francium. Now, so that's why you can see the blue, red, and white in the background there of the French flag. Now, radioactive. Okay, first of all, what is radioactivity? Radioactive. Right, I'm going to try and explain this in less than a minute. Now, let's quickly pull up the atom again. Here we have francium. As you can see, it's very big. Now, it's a very big atom with lots going on. It's very heavy. And radioactivity is very simply, as basically as I can put it, in the centre here you have the nucleus, which has got protons and neutrons, and radioactivity is when this part, the centre, the nucleus, is unstable for some reason. It doesn't work, it doesn't fit together nicely, and in order to balance itself, it will spit out or get rid of a particle or a wave of energy, and that is radiation. There's different types of radiation, but that's it in a nutshell. So you get what's called a radioactive decay chain, which one element will turn into another, and most radioactive elements ultimately turn into lead or bismuth, where they're pretty stable. Now, there's more radioactive elements on this table. I'll quickly pull them up. And you'll notice that they all have this sort of sparkling effect around them, multicoloured sparkling effect around them. So we've got, over here we have francium and radium. On this side of the table we have these three nasties, radon down in the corner there, astatine polonium, and bismuth is radioactive. It's only just a tiny bit radioactive, so it's got a small sparkling effect around there. And then we have an odd one out. If there was a party for elements, this will be the last one arriving at the table, really. Technetium. It is radioactive. I'll go over that when we get to it, which will be quite a few days away. But there is a reason why that's sat all by itself on the table there. So that's technetium, which means artificial, because it was made in a lab. Anyway, now francium is super rare. There's only one element which is naturally found on the table which is rarer, and that is astatine over here. And at any one time, I could hold the amount of francium in my hand, which is in the entire world at any given time. Although I wouldn't want to hold it because it is wildly radioactive, and radioactivity can damage cells. In fact, tragically, that is how Marguerite Perret, she lost her life. She passed away because of radioactive poisoning. And the world record for getting francium in any one spot at any time is 300,000 atoms in one place at the same time. Now that's tiny, really small. You'd need a very powerful microscope to be able to see that. So there's no experiments really being done with it because no one's got enough of it in one place at the right time to do any work with it. That's why I've designed the card with this sort of like, he's very blurry and you can't see him, because no one's seen it ever, not with the naked eye. And its uses, well, its uses are only really for nuclear atomic research, and they are looking to see if it's got any uses for cancer, and that's about it really. And that is the last of our alkaline metals. And the next one we'll be hitting will be beryllium up there in the corner, over here. And that is an alkaline earth metal group. So thank you very much for tuning in. Don't forget, as always, if you want the high definition artwork, just go to elementskapa.com, leave me your email, and I'll get this email to you in one big file. Okay, thanks a lot. Bye.